Welcome to the CTO2CTO podcast, where Chief Technology Officers dig into the challenges and opportunities that leaders face every day at the intersection of business and innovation. I'm your host, Lucas Hendrich, CTO at Forte Group.
Welcome to the CTO2CTO podcast. I'm your host, Lucas Hendrich, CTO of Forte Group, and today I'm with John Higginson, the CTO of Curriculum Associates.
Hey, Lucas.
How's you?
Good to be here.
So, to kick off, we're going to start with a topic that's, if not beat to death. So apologies to anyone out there who's heard too much AI hype, but it is relevant. And particularly, I think, with the products you're working on, I'm really curious about how you're integrating AI into the product stack, into also ways of working as well, and anything you want to say about it, we're really curious about.
Yeah, it's I laugh because I feel like as an industry we were infatuated with crypto, and then about 3 years ago we just crossed crypto out and put AI. It's obviously a lively topic, and not just product development internally, but customers ask us, our board asks us, things like that. So let me start with our mission is to help teachers teach and help students get to better outcomes. Our chairman of the board, who used to be our CEO, would always talk internally about a kid never gets to take third grade again. So we take that very seriously. We also take very seriously privacy, because one of the challenges with AI, like all the promise of AI, is that it requires data to be able to deliver on that. It has to be trained on data that you have, things that it learns. And so there are real privacy concerns about that. So we kind of start from whatever we do with AI for our products, is it good for teachers to help them teach? Is it good for student outcomes? And over all of that, does it protect student privacy? To that end, like the AI lab that we have. So we acquired a company about a year and a half ago called Soapbox Labs, which did some really pioneering work for speech AI, where software listens to a kid read a passage, and then it will analyze that and say, here's the rhythm of the speech for that student, here are the phonemes that they pronounce correctly or incorrectly, and give the teacher a roadmap for how they can teach them to be better speakers, better readers. All of that, it has to be trained. So we have a process to get real kids' voices, but anonymize that, protect their privacy, and then obviously the recordings and that to be able to protect those and anonymize that, to the point where we're the first company in our space to get a digital promise certification from an entity in Europe about protecting student privacy. So that kind of drives all we do. As we think about AI in products, it comes in a few forms. So obviously that, which is, you can put that under the kind of the broad rubric of assessment. Like, how do we help teachers understand how students are doing relative to their grade level? Speech reading is one of those. There are other applications of that. Another is just helping teachers get to the right resources. So one of the ways you and I use Gen AI and use other things is to look up stuff. Like we used to Google it. We're both around long enough to have probably used encyclopedias. But now,
which is crazy to think about.
I know. Yeah, I feel nostalgic for the old books. I want to go find them. I remember them on the shelf. And but now you use AI to do the research. And so AI trained to materials teachers need would be a helpful thing. And then, we do a lot of content. And so as we've seen, all the demos of, images and things like that, we want to make lessons engaging. And we think that AI can be a really powerful way to do that too, to make images and other things that will, make the 10-year-old sit there and enjoy the lesson, do that. Internally, I think a lot of companies, from an engineering standpoint, we've embraced things like Copilot. We're looking at how AI can help us build better tests when we're developing software, and just in general, take away some of the things that is more busy work, but get that off of people's plates so that they can do more impactful and interesting things.
So if you were to, let's say, design an organization from scratch,
Yeah.
today,
Yeah.
where typically you might be thinking on some, order of magnitude of, 20 to 30 people. How does that look now? How would you staff that? And how would you think about the capabilities? How would that change the software development lifecycle for you?
I think, so you think about AI and technology, I actually think a little bit differently about some of what's been said in companies like Salesforce and that about, well, we don't, AI will replace this class of engineers. Because my experience and our team and our engineering team, collectively it's about 400 people, it's actually engineers who have some level of experience and some level of discernment that get the most out of AI. Mm-hmm. And so I would take it more from AI literacy is like a prerequisite for the people we bring in. Like an engineer who would say, oh, I don't need that. An engineer in 2025 who says, I don't need AI, I don't need Copilot, I don't need Claude, Cursor, whatever the tool is akin to an engineer, 10 years ago saying, I don't need Stack Overflow.
I don't Google anything.
I don't Google anything. Yeah. Or 10 years before that, I don't need to like have the developer network or books. Like, so I think AI literacy is really important. And then I think it's figuring out where you put AI and technology into it. It's a different way of using the technology, but I think, you still have software engineers, you still have UX designers. The UX designers are probably doing more first draft work that's generated for them, and then they're refining it. The testers are probably doing like first draft of tests, like the product folks are probably doing first draft of stories, but the team still the same. It's just like they have other ways to get there faster is how I look at it.
I'd say, the way that we look at it is very similar, that it's becoming a way of working more than anything else, and extending capability more than replacing. Mm-hmm. And I think it's interesting because the noise around this tends to provoke one of two points of view. And the more common one that you hear on the fear side is that, it's going to replace jobs. What are we going to do? Mm-hmm. Kind of a Malthusian view. Whereas I think the real change, which we haven't even seen yet, is how it's going to create new opportunities, new job descriptions, essentially, new ways of working.
Yeah. No, I agree. Not to get all philosophical on this,
that's what we do here.
but I do, like, if you go back in, really like to the Industrial Revolution, like that has been the evolution of technology. And I think the thing we have to recognize as leaders and as companies is it is disruptive. Like I don't think we do anyone a service if we say, don't worry, it won't feel disruptive. It will feel disruptive. It just in the same way that, people, my grandfather worked in a steel mill, and in his lifetime, it went from like a bunch of human beings with hammers to automation of some kind. And like, that's been the march of technology. And so his job changed. Like his job changed from swinging the hammer to, running the automation and running the factory line. And I think what's incumbent on us is to invest in the training, the education, the making it safe for people to experiment in doing that, because it will change. Mm-hmm. And that's a good thing as long as we bring people along doing that.
And I feel like we're kind of on a razor's edge with that as leading engineering organizations, because on the one hand, you want to make it part of the institution. You want to, people start working for you. You want them to get training in what tools to use. You want to enable them. On the other hand, that entire landscape changes almost every day.
Right.
How do you reconcile it? What's your view? What's sort of the buffer for risk that you manage?
I think it depends on organization size, right? I think one of the luxuries of being bigger is we can actually carve out time to say, like, let's do some tech talks on this particular technology, or let's do a hackathon, because we do a hackathon every year, and give people space to just experiment, do it. It serves two purposes. One is it feels safer for people to try things without like me coming down and saying, okay, we're going to change I'm not doing the Jeff Bezos services in AWS memo where I'm like, everything's got to be a service. If you don't, you're fired. Have a nice day. It's like, we want to try these things, and what works, we'll scale. And the other is it just lets us learn as an organization. I think in smaller organizations, that same thing happens, but it's usually champions. There's usually people in like a 30-person engineering org who say, I'm going to go off and play around with this, and then I'm going to come back and talk to you about it. And that works in that organization because, it's small enough everyone can get in the same virtual room and talk about it. I think I having been through technology shifts in engineering organizations, I think a lot of it comes down to being able to both encourage people, like find champions, have people run with it, and like create some some incentives, some ways to push people toward that. I know some organizations are toying with or have talked about, well, you must do this, you must do that. I would take it from a different approach of, we're going to give you the tools, we're going to show you good examples of how they're using, and then as a team, we're going to have a goal that measures how effective we've been at doing that. So we're going to succeed or fail together, and do it that way. Because mandates are really hard, painful ways to drive change in org.
Oh, and I think we're still very much in the measurement phase too.
Yeah.
So we're trying to model this stuff.
Yeah.
And some of the I guess the initial findings that we have data on is, if you use Gen AI for unit tests, that's low-hanging fruit, and it's a 10x multiplier in productivity. Or spikes in a sprint. So what would take 2 or 3 days to build a prototype that is a throwaway, or potentially now you can do that in 2 hours or less.
Yeah.
So that's a huge productivity gain. If you try and apply the same approach to something that's very domain specific or algorithmic, you might get 85% there in one shot, and then from there you're degrading your progress trying to refine it. Are you finding similar?
Yeah. I think it goes back to it's great for first drafts of things. It's great for prototyping things. The example I've used recently is, if you want to use a service, an endpoint somewhere out there, like the Google Places service or something else, it's, why would you write it? You can figure out how to write. Just ask one of the LLMs, generate this code stub for me in the language of your choice, Ruby or Java or whatever you want to do, and then play around with it. I think when you get into more complicated things that are at the essence of the software you're writing, that's where the experienced engineer gets more value out of it than the junior engineer who doesn't know the domain, the context, what's in there. And I think that's true. I also caveat that by saying it is evolving rapidly, and AI is getting better, is giving better answers, and this coming, it's still early days in agentic AI, where AIs are linking together to perform complicated tasks and handing them off. There's some cool demos of that, and there's some cool use cases that also will get more sophisticated. So I think, to go back to the root of your question, I think we have to maintain that curiosity as engineering organizations. I still think we all got into this because we saw this future that didn't exist yet. We're like, oh, I can see where that's going to go. And that's why we got excited about computers and the internet. And, and I think we have to maintain that curiosity. We can't fall prey to, we figure everything out, there will be no more inventions ever again. The end of history. So.
No, I agree. I think it's more about changing how we work and how we produce things, and than it is about this wholesale replacement of humans.
Yeah.
And it almost makes me think, the pursuit of an AGI, is that even going to be that useful when you have all these very practical uses for maybe smaller trained models? So Soapbox as an example, how the model that you use for voice recognition is not the same that you use for wholesale language development. So
Yeah.
as that becomes more specific to different areas, it makes me think about, the human body and intelligence, how the model that your eyes use is not the same model that your ears use or your gut. And these are all part of your tactile experience in the world.
Yeah.
So I think that's encouraging because there's so much room to grow there, as opposed to just racing to this, to the bottom of commoditizing intelligence.
Yeah, I agree. And I think it comes back to like, it's not what the product is and does matters. It's not just about, cranking out more, I don't know, plastic rubber ducks. Like,
right.
We're creating complicated software to solve really complicated, challenges, whether it's in schools or it's, running a business or it's, running a website. And so the human part of that, about that design, that creativity is where we want people to focus on. And the real promise of AI, I think, is freeing people from all the other stuff. Like if I could get an AI to do budget and forecasting for me, man, here's my credit card. Like,
and how about have the conversation about it?
Yeah, exactly. Like, somebody like
reach the conclusion.
Yeah, I'd rather focus on other stuff. But like, that's, I think that's the promise of it. It goes back to like, we have to be curious about it. We have to learn, adapt, figure out where it works. And we have to recognize that it will be disruptive to people because, like it's a big shift, but there have been other technology shifts. Like there was a time when if you were a software engineer, you had to build all the UI. And you had to build it in code. You don't do that anymore. Like there was a time when if you couldn't figure something out, you were kind of stuck. But now you can't. And I think if we had stayed frozen in like, well, this is the way it is, like then we wouldn't have AI. Like we wouldn't have a lot of things that we take for granted.
Yeah, I totally agree. And I think the sort of shift of taking what was human cognition to machines, it's actually making cognition more efficient. So if I have to, or, writing code, think about it like data entry.
Yeah.
Do I need to do all these keystrokes for something that the result is a pattern that should reflect a broader pattern, which now you get from an LLM.
Yeah.
But if you have to do a hard cognitive task, and usually those involve human attributes like intent and curiosity, then you're just creating more space for that. So
right.
That it's a more efficient use of human cognition, which I don't think you can, and maybe I'll be proven wrong, I probably will be, but I don't know that you can model human curiosity in the same way.
Yeah, it's
purely
with
really, LLMs.
Yeah, it's really hard to see, and like the LLMs are, a lot of them is like they feel magical because they're trained in so much data that they're just really good at knowing like this follows this, and that's the way a lot of LLMs work. I do think like design is something that won't leave the hands of humans and go to AGI. I think it fundamentally like creating software for people to use, whether they're adults or children, like that's something humans could do. But there's a lot of things that go into that from I think of it from a DevOps perspective, like, okay, I need to create a dev environment, and I need a database and servers, I need a web server. Like people can do that, but you'd rather have them focus on building the product, like design the product, than like that.
Precisely.
Let AI.
Precisely. I could make candles and light my house.
Yeah, exactly. Yeah.
It's quaint. It's a fun hobby.
Yeah.
So one thing I love about this podcast is that, and I think this is reflective maybe of our generation, that you have people with such diverse backgrounds. And I don't know that someone could actually model what is the CTO background.
Yeah.
And when my kids ask me, what do you do? How do you explain it? All of that is part of sort of managing multiple disciplines, and different organizations might index more on each discipline. You come from a legal background.
Yeah, well, even before that, from like a liberal arts background. So yeah.
so I'm curious about that. Like how does that inform you? I think, or what perspective does that give you that might be different from your peers?
Yeah, I really found like my educational background, which is highly unusual, for what I do and what I've been doing for the last several years. So I should explain it because it's probably helpful for that. So back when I was a kid, when I was like 11 or 12, like I was a computer kid. It was the dawn of the PC age. My grade school had TRS-80. So for any of the people who might watch this who are younger than like 40,
We had big 40s.
45, they'll have to look that up. And then I had a Commodore 64, and I taught myself how to code. I took classes in high school. I actually badgered the principal in my high school to let me create my own independent study year for computer science. And then when I got to college, it was a lot of repetition of things. In hindsight, with a lot of hubris, I thought I knew, and I just didn't do it. But I'd always been interested in like storytelling and literature, and so I focused on that. And that was my bachelor's background, is that. But I never stopped coding. In fact, I had friends in college who I would help with their computer assignments, and they were CS students, and I wasn't. When I got out, my first job was as an engineer, and I worked on lots of different stuff. At one point, I was even a network engineer because we used to do everything. In that era. And then after we sold Applied, I went to what's now UIC Law School. It was John Marshall back then, and I focused my legal studies on privacy law. And so to take a step back, like how that changes the way I think about things. So what I've learned over time being a CTO is that this job and leadership is way more about people, and it's way more about communication than it is about technology choices. Don't get me wrong. I love to nerd out about whatever, you want to talk about Rust, we'll talk about Rust. When containerization became more accessible on AWS and on GCP, I'm like, yeah, let's talk about that. I want to see how that works. But to get a team, if it's 30 or 300 or 400 people to work together, is about being able to talk to them about where we're going, about the mission, and with customers, to be, like you talk to customers all the time. They don't want to talk about technology. They want to talk about the outcome they want.
Business
you wanted
results.
the story that's going to end with them getting what they need to run their business. And so I think a lot of those communication skills, the kind of the appreciation of all the different ways that ideas come into software development has been really, really helpful. Steve Jobs years ago had talked about how Apple wouldn't have had fonts if he hadn't taken a calligraphy course in college. And I think about that a lot. There's a lot of things that wind up in the software that I've helped work on that have echoes in other things I study that have nothing to do with computer science. And then the legal background, privacy, that obviously has become huge. It's such a key part of our obligations at Curriculum Associates. It's been a key part of roles I've had. And as we enter this world where all of our data is everywhere and everyone's concerned about malicious uses of it, or of attacks, hacking attacks, phishing attacks to get that data, being able to think about that and understand not only what the obligations are, but also what the broader thinking in the industry is about privacy is really helpful too.
It's also interesting how, I guess the way that just purely from the outside looking in, people talk about legal frameworks.
Yeah.
And frameworks are the most interesting part of technology, in my view. As far as you're defining an architecture, it's incredibly important that you do it in a way that will persist over time and not degrade over time, and it always does anyway. But using frameworks, using patterns, how things become widely adopted in a scalable way is extremely similar to how do we create a legal framework to deal with some issue in society or deal with privacy. So I see a ton of parallels there. And I think being a CTO is much more multidisciplinary, must be.
Yeah, it has to be, because you're asked to do so many different things in the role. You're asked to be the liaison between the other parts of the business and technology. So you have to be able to sit with the engineers and talk about how they're building things. And then you have to go to the board and explain, here's what we're doing, here's why we're doing it that way, here's how we can adapt something like AI. You do broader product development, you have to have a sense of marketing and customer storytelling and things like that. and then overall, it is a little bit of like being, pick your metaphor, like, the fun uncle, the the teenage dad, the soccer coach, where you have to get a bunch of people who come, from very different backgrounds, who are doing different jobs, to understand each other, work together. And it's all the same, that you have in a team, like you in a sports team or anything, like you have different personalities, and different people are driven by different things, and be able to smooth that out. And that's why I say, like, it's so much more than about technical. I've done mentorship here in Chicago with a few different groups, and what I always tell newly minted engineering leaders is, what you think is your most important decision, like, oh yeah, should we start using Golang to build our services? How hard should we lean into Lambdas? Actually won't be as impactful as a CTO, at least, as do I have the right people? Have I told them, have we collectively decided on the right goals? Like, are we aligned about what we're delivering? Because best technology in the world, rests on people to deliver it. And
Absolutely.
if you don't do that, it won't happen. Absolutely.
And I'm curious what your thoughts are on this too, is that, as new technology, I always think about it this way. If you were to come to this planet and your only source of information was LinkedIn, you'd think that every company has already started implementing agentic AI for everything.
Right. Yeah.
Where the reality is, many of the companies that we work with, that we help, they're facing technical debt that goes back 20, 30 years. So how do you balance that? And I'm not going to ask how much exists in your company, but
we have none, Lucas.
Yeah, that's wonderful.
We're unique.
You're all totally agentic. We can all go home now.
Yeah, it exists in every company, right? And the longer you've been around, and it exists for good reasons. Like I grew up in the insurance industry. That was the first industry I worked in, and although we were building software, modern software, we still had to rest on the entire infrastructure of the industry, which then and now is largely COBOL. And it has stayed COBOL because a lot of work went into building a scalable, long-lived, well-vetted quality system. And so a lot of the processing that remains because it works. And I think with tech debt, or just like embracing things, like it's always a balance. There's never a time I've in all these years, like I've never been a time where, we've got a year where all we have to worry about is retiring tech debt. Never happens. Like, you make targeted improvements or retirement. Every once in a while, you do have to like kill off an entire system because it just, it doesn't work anymore. It doesn't scale. But usually it's more evolutionary when it comes to that, bringing those things in. And then I think with tech debt, like the thing that people kind of learn over time is there's good tech debt and bad tech debt. There are things that just work that it's not worth it to change. And that's like the insurance COBOL example. And there's things that don't work, that, you do want to change and you want to apply technology. So, but what I found is it's always an evolution. It's never like a big bang. Yeah.
Well, and I think there's also, the technology, is saving us from this crisis around who knows COBOL. Right. Well, train the models.
Yeah. I mean, I've done this. Like I've gone back and I've asked like Claude or ChatGPT. I'm like, give me this app, or, do like this number sort thing, or like this app and do it in COBOL, or, do it. Forth was actually after BASIC. So Forth was the first language I learned, which as far as I know, nobody used anymore, and then it was C, which lots of people use, but I try I can't remember like how you would do that. So, give me this in Forth, and, it spits it out. So that helps. Like that helps a new generation of people maintain a code base. I don't think has been written about recently. Like you can just ask AI to like totally rewrite like the millions of lines of COBOL that exist out there, and it'll be all good.
But I think in terms of synthesizing, understanding it,
it's understanding it. How do I, this? I want it to do this thing, so this thing, or there's this defect. It can help you do that.
Yeah. It's going to future-proof us in a way because that code will persist as long as someone doesn't touch it. So
yeah, and it will help us with that generational divide, because obviously we're not really turning out CS grads that know COBOL or some of the other languages, but it will allow people who have good engineering skills to appreciate and understand that, because like a lot of the concepts are the same.
what I wonder is, I think that, safe to say for the past 20 years, we've been following an agile methodology for developing software. When you start doing data experiments and then incorporating that into your product stack, it kind of changes the time cycle a bit. Have you found that, and how are you, is it disrupting your development cycle?
I think what we're still grappling with is how to create enough space to do that experimentation. So there's always the time frame pressure, no matter what you're working on. It's like, we need to get a certain number of things done. Like, we run on a school cycle, so we have pretty hard dates around when we have to have things done and delivered. But we also want to try some things. We also want to learn, and things happen in development cycles. And so, whether it is the hackathon that I mentioned, it is, doing spikes in the sprints, where we could say, we're going to do a spike to look at this or do this data research. That's the approach we've taken. I don't know that it gets us all the way there. And, I think like a lot of companies, we're just sort of still trying to figure out how to do that, like how to balance experimentation with the pressures of the roadmap and things like that. And I think, with Agile, Agile is also a framework. It's not a set of hard and fast rules. Is how do you adapt the way you use Agile to actually do that?
Maybe it's about when decisions are made too. Like, I think it's a reasonable future scenario that you go into planning, right? And you try and have some sort of, maybe it's one sprint, maybe it's 5 or 7. And then in that, you might be putting the research work up front to solve some uncertainty issue. Mm-hmm. If you can solve that uncertainty issue, vibe coding in 15 minutes, maybe you could do that, with leadership, and just take that whole planning cycle and reduce it incredibly.
Yeah, that's interesting.
It's almost like you could have 5 different scenarios you're looking at once, and it's like creating a canvas. I built something the other day in a language that I don't know, and deployed it on my local machine with an interface, and I could actually start building a product in about 2 hours. Not very sophisticated, but something that another platform that I could pay for is doing. Having that canvas, all of a sudden you're iterating on how to improve it much faster. So that's what I think is really fascinating, is that research
it's an interesting idea, like just being intentional about
conclusion that might take you 6 months to reach.
We're
you're doing Agile,
Yeah, I like that. Yeah, just to be like, we're gonna carve out time to do that, like to look at it, play around with it.
Yeah. So this is a provocative question, so answer it as much as you'd like, and please don't take it as a
like, hold on,
poking at the moat. But I have 3 children who are actively engaged with LLMs, let's just say, in doing their homework. I think it's fair to say this, the teachers would probably not want to hear this, but I think it's a fact. You can't, it's out there, it's in the wild. Mm-hmm. And one thing that I particularly like is they might have a teacher that explains a concept really well for 80% of the kids, but 20% just don't get it. Mm-hmm. And that creates a frustration, and they lose interest. Mm-hmm. Whereas you can kind of repeatedly ask, tell it to me in a different way. Tell it to me in a different way.
Yeah.
At no cost.
Yeah.
How is that working into the product vision? That kind of interactive, let the student really determine what their learning path is.
Yeah, so that's interesting. So we actually do, we would agree with like the personalized instruction, is what we call it, is really important. And I think AI can play a role in that, but there's a couple of things that also have to go into that to make it successful. So one is, it's really important to understand, and this is something that off-the-shelf LLMs don't always do well, where a child is relative to the grade level and relative to the grade level of the curricula. Mm-hmm. because in school districts all over the country, you can have kids who are in fifth grade who read at a fifth grade level and understand math at a second grade level. And that changes the way they run the same classroom, how you teach them. And that's a lot of what our software, like kind of pre-Gen AI, has always been doing, and where Gen AI plays a future role. The other is helping teachers understand how to individualize that, which is what your kids are using AI for. Like, give me other examples. Our vision of that is helping teachers teach that in more and different ways, and give them the tools to do that in the divide. But it's still a real thing where students universally don't have the same level of access. And so we try to do with iReady, which is our software suite, is it provides those tools to schools buy it so they can use it in the classroom. So they may not have it at home, but they'll always have it in the classroom and through that. I definitely think that Gen AI in particular, like using LLMs to like give examples to help kids understand things or help teachers do things, is an important part of that. And I can, I certainly see that flowing into future generations of education software. I think it's just really important to make sure that it is teacher centric, so the teachers can help do that. It is also aligned to where that student is, so that we're not making mistakes about what level they're being taught at. And it's something that can help every student grow, not just students that
that's great. It makes total sense. You can kind of, at the margin, you could imagine an extreme where students are creating their own bubbles of thought, where it's, who knows, right? Like one hallucination could take you down a path, and it's hard enough to figure out what's true anyway.
Yeah, well, there's lots of great examples, right, of things that there used to be a podcast called, things I learned in history, right? They're all wrong.
Yeah.
None of that actually happened. It didn't happen that way. So,
yeah, especially if and I find this, especially with early iterations, now not so much, but the story is so credible. That's what the LLM is really good at, but absolute nonsense at the same time.
Yeah.
Speaking about mentorship and also, I guess, thinking about the next generation of, will we call them engineers? Will we call them product designers? Like, what do you think? And this is an impossible question, but but I got to tell my kids something, because one of them starting college next year. Let me preface it. I feel like there's a shift going back to more critical thinking orientation and less pure technology as technology becomes easier to implement, at least, the core stack. What are your thoughts there?
Yeah, I think that's true. I think that's always been important. And I think what somebody who is, 22, just out of college, will most benefit from is curiosity and critical thinking, because I'm willing about you and I could take a moment. We can write down the operating systems, the programming languages, the frameworks, the technology stack we used when we started our careers a year out of college. And I bet none of them are what anyone is learning today. But like, we learned and adapted because like that was part of it. And I think understanding how to like analyze a problem, forget about what it is, like how to break down a problem, is a critical skill in technology, whatever the role is. Being able to collaborate with people, because like when I was a kid, in my room with my Commodore 64, I'm like, I'm gonna be. I love to play the Infocom like text-based games. Yeah. Those were all developed by and large by one person. Like one person would be like writing the game engine and the game content. Like that can be. There is no game on Xbox that is one person writing it. There's probably no game on like iOS or Android that's like one person. So being able to work with people is the other really important part. And that's why, going back to something we said earlier, like I think sometimes in tech we over-index on tech choices rather than building resilient people who will who'll be able to learn and adapt as technology changes. I think as far as what they'll be called, I had no idea. I think, when I started out, it was, programmer was still the term of art, and then it was software developer and software engineer, and then everyone's an engineer. So who knows? Wizard? Who knows? You can't predict.
Yeah. No, I think that's, I totally agree. What I think about too is it feels like when I started working in technology, there was a gap between even what was being taught in a traditional computer science discipline and really the landscape of essentially commercial products at that point, but basically the platforms that you'd be working with, the languages that you'd be writing code in. And so I think about now that might be it's becoming a totally natural language interface, not across the board, but it's moving in that direction. So I wonder how that's going to change our language itself. The LLMs are a reflection of who we are and how we speak. We want LLMs to help us synthesize and become more concise. Maybe we'll become less verbose as humans. I don't know.
Maybe. Yeah, it could be. Yeah. Or maybe we'll win over the machines and we'll make the machines more verbose. Yeah. No, but I think that's true. Like prompt engineering is, yet another step toward that abstraction away from like low level coding to more human language, telling the machine like, here's what I'm thinking, and having it actually do the hard work of putting the code, the binary together. And you can definitely see that trend continue. It's been happening with like, think about access to data. Like it used to be if you wanted to do any sort of custom query, you needed somebody with a knowledge of SQL or some kind of engineering background. But today you don't. Like if you look at like the new version of Excel with Copilot, like it can interrogate spreadsheets in the way that they would two people talking together.
So access to data, I think I agree, is going to become the larger problem to solve than building transactional applications. I feel like that's wrangling the data, being able to handle data in different formats, integrating that data, the insights,
currency, accuracy. All that's going to be really critical. And it'll be interesting to see data, particularly in the era of the web, like from the mid 90s, data's been as free as it's ever been. It'll be interesting to see if that gets pulled back. If companies began to see themselves as not, being in, whatever business they're in, but being in the data business. And so, I've got all this data that's really important to this large language model. So, what are you going to pay me for it? It'll be interesting to see if there's like a class of companies that's just all about like data accuracy, aggregation, cleanliness, and they start to resell it that way.
I agree. And also the structure of that data. So it's informed, I think, how we create internal documentation. You want it to be LLM readable. Right? So in a broad sense, SEO is maybe going to go away. It's less keyword focused. It's more structured focused. As that's going to be the ease with which you can obtain information using LLMs. Fascinating to see it go.
That's interesting too. That makes sense because I think you've already seen like web traffic decline for Google Next. People are using AI as kind of a search tool. But this idea of like all the SEO black arts that we've been doing for years on web development just go away.
Are you excited about the new frameworks that are coming out? Because I feel like, and this is something that's day to day as well, like model context protocol, the A2A. Is that making its way into your,
MCP is, we started talking about it. So like it, and again, like, everything's different, but it's still the same. Like this drive for like, okay, now we have all these tools. How do we build middleware to make it work together? How do we knit the two? And that's a key part of like agentic AI. And so I think what's now being developed framework wise about how you get different LLMs to talk to one another and how do you pass tasks back and forth and make that work, and then make that work in whatever your deployment environment is, how you test is that in the last like probably 2 months, like that's the thing that's most interesting to me.
Is it funny we say 2 months now?
It's
that cycle is and I think that in a sense adoption of frameworks to me is going to, I mean, right now people index a lot on benchmarks, and this model just achieved this benchmark and that benchmark. And for the common population, I just don't think that makes any, there's no, people don't really know how to understand that. Like, what does good look like?
Yeah, it's changing so rapidly, and it's hard to understand like the context of it. Like, one thing we've talked about internally too is we built some things using, that are like RAG chatbots that we use internally. But RAG probably goes away, because when the number of tokens you can have in a prompt is in the millions, why would you train anything? In that sense, for like a chatbot like that, you can just put it all in the prompt, and the prompt can be this kind of living thing. So, and
that's what makes it so hard to actually build architecture, because 2 years ago you may have built your own vector database and done all of that, with Python in the middle, and now it's just a service, and it's built in.
Yeah, the people who are in data science these days, like, they're really at the disk is spinning fastest for them, right? Like in infrastructure, it's changing, but not as much. And like software engineering is changing a little more rapidly. But if you're in like data science, things are going really fast.
Yeah, absolutely. And it's if you were following things 20 years ago and reading white papers, the compute power is such that everything is possible.
Yeah, I mean, well, this is like, we used to play, remember Eliza?
Yeah.
The first, computer therapist, which was
when you're, exactly. When you were talking about, one person writing games and those text games, I was thinking, you died of dysentery, right? Oregon Trail.
Yeah, I can't make it to the coast. Yeah, but like Eliza, like people using LLMs for therapy is a real thing. And it's not, I don't think it's recommended by psychologists, psychiatrists, but it actually gets much, much closer to what a human therapist would give in terms of advice and things like that, where Eliza was just like a game.
Right.
But compute power, access to data, train data makes that, more of a reality.
Yeah. Well, and as humans, we love to anthropomorphize things, right? So we love to believe in the magic.
Yeah.
John, it's been wonderful talking to you.
Lucas, thanks for
joining us, and hope everyone out there has enjoyed this conversation as much as we have.
Awesome. Thanks, Lucas.
Thank you.
This was it for this episode. Join us next time for more real-world conversations between technology leaders. And if you like what you heard, subscribe to CTO2CTO. See you soon.